Welcome to EDU World Space.
Problem 3.90. In this problem, there are three forces are given that are acting on the system, and we have to replace these three forces by an equivalent single force. So for the calculation of equivalent single force, one can observe that these two 50 Newton forces are anti-parallel to each other because both are making same angle with the vertical axis. So they will have no effect on equivalent force because they will cancel out each other. So the only effect or the only effective force acting on this system for the calculation of equivalent force will be 48 Newton. So equivalent force will be 48 Newton, and I am considering the axis, this axis to be x-axis and this axis to be y-axis. So this will be minus j prime. So equivalent force is minus 48 Newton j prime. Now, for the position of for the location of line of action of this equivalent force, means this equivalent force is going to be vertical line. So for the location of vertical line, first of all, we have to calculate a total moment about any point in the initial system and equate the moment from it to the from the equivalent system. So let's say that first of all we have to draw a diagonal line on this rectangular plate. Let's say this is AC and it is making an angle theta with the horizontal axis, and this tan theta can be calculated from the triangle as BC divided by AB, and which comes out to be 240 divided by 400. So theta comes out to be 30.96. Now for the calculation of moment, we should wisely choose a point from where maximum line of action crosses, because it will give zero moment for all those forces that are crossing from that point. So let's say in this problem, the point is C, because from point C, the moment, if we consider the moment about point C, the moment because of 48 Newton force and this 15 Newton force will be zero because both of these are passing through the point C. So the only moment will be because of 15 Newton. So it is going to reduce our effect. So for the calculation of moment about point C, so this will be let's do one geometry here, that we should draw a perpendicular line from A on this line of action, and let's say this is M and this angle is 90 degrees, and this perpendicular will be now angle we can calculate it from here, that this angle is alpha and this angle will be 90 degree. So this angle will be 90 minus alpha, and if this angle is 90 minus alpha, and now these two lines are perpendicular to each other, this force and one perpendicular that I have just drawn here is line AM. So this force and line AM are perpendicular to each other. Now this angle is already 90 minus alpha, so this entire angle will be alpha. Now this entire angle is alpha, that is angle BAM is alpha and angle BAC is theta. So this angle is going to be alpha minus theta. So length AM can be written as AM will be equals to AC cos alpha minus theta. So perpendicular distance AM is known, so we can find out the moment directly here, and that will be, since this 15 Newton force is going to cause anti-clockwise couple, so this will be positive 15 multiplied by AC cos alpha minus theta. In the first part, alpha is given as 40 degree and theta we have just calculated. Now we need to calculate the value of AC, and AC is the diagonal of this rectangle. So AC will be under root of AB square plus BC square, and AB is given as 240 mm So 240 square plus 400 square, and which comes out to be 466.476 mm. Now AC is known, so we can put it here. So the moment about point C comes out to be 15 multiplied by 466.476 cos alpha, that is 40, minus theta, that is 30.96, and this moment should be equals to, let's say that our line of action of our force is passing through this line, which is at a distance d from line BC, or from point C. This line is at a distance d from C at left. So it will be our equivalent force is 48 multiplied by d. So we can solve this and equate these moments, and from this equation d comes out to be 143.963 mm. So our line of action in first part will pass at a distance 143.963 mm left to the point C. Now in second part, they have already given the line of action of the equivalent force, and that is D is already mentioned in the problem to be 300 mm from point D. So from point C it will be, let's say, D dash, so D dash will be 100 mm since the entire distance is 400. So in this problem, in the second part, they have given this distance. So this distance is 300. So this distance will be, that is from point C, will be 100 mm. Now we can use this relation again. So in this relation, what was the moment equation? We can write it here as moment about C, that was written here, and that is equals to 15 multiplied by AC, and we have already calculated AC, and that is fixed for the entire problem, 0.476 cos alpha. This time alpha is unknown, but theta is still known, that is 30.96, and that should be equals to equivalent force, since equivalent force is not going to change. So 48 multiplied by d dash, and d dash is the distance from point C. The problem, it is mentioned that this distance to be 300, so this distance will be 100. So we are going to use here 100, and in this equation only one angle, one is alpha is unknown, so alpha can be calculated by using calculator, and alpha comes out to be 77.646 degrees. So this is the final answer.